So today I want to focus on a couple different things that are going to appear in 1.3. The first thing that you're going to have to be able to do is you got to know how to evaluate expressions. And this just means figure out what an expression is. So we might have something, we might have an expression that says something like this. I'll say 4x plus 2. All right. You can see there's no equal sign. That's what makes it an expression and not an equation. But if I were to say 4x plus 2, and then I'd say when x equals 3. So to evaluate it, all that we're doing is we're going to be substituting in 4x. Okay, this is what we're going to do is we're going to take this 3, and anywhere we see an x, we're going to put that 3 in for it. So that 4 times 3 plus 2. And then when we evaluate it, we'll do 4 times 3, which is 12, plus 2. And then finally we'll get our answer to be 14. So when I evaluate that expression for when x equals 3, it becomes 14. Now we might have something a little bit more complicated. Okay, we might have something a little bit more complicated. For example, I might say something along the lines of, I'd say 2a plus 7b minus 4. I might say something like this. And I want you to figure it out when a equals 3 and when b equals 2. All right? And so to do this, we're just going to go back to our original expression and we're going to substitute in here, right? So I'm going to say 2, and then that's going to be times 3, because that's what my a is, plus 7, and then that one's going to be times 2, because that's what my b is, and all of that's going to be minus 4. Now that I have this, I just have to evaluate this. 2 times 3 becomes 6. 7 times 2 becomes 14. And finally, we'll be subtracting 4 from all of that. 6 plus 14 equals 20 minus 4. 20 minus 4 is 16. So when we're evaluating expressions, all that we're really doing is we're looking for what these variables are, and we're going to plug in those numbers and then perform the functions that it asks us to do, whether it be multiplication, division, addition, or subtraction. That part is easy enough, but I do want to go on to another section that's going to be a little bit more challenging. And what this is going to ask us to do is I want you guys to be able to justify your work. And justification means that you're giving a reason for doing what you're doing. Okay? You guys are doing things for a reason. So let's imagine I had something like this. I had 3 times x plus 2 equals 15, and I'm asking you to solve this, but then also justify. And I'm actually going to be asking you guys to do this in tonight's homework. And so what I want to do is I want us to be able to talk about the different kinds of justifications that are appropriate. The first type of justification I want to talk about is when we're looking at something like this, one of the things we might do is distribute. Distribution. Because the first step here is going to be to distribute that 3 to the x and the 2. So 3x plus 6 equals 15. And so the reason I have done this, I have multiplied that 3 times the x times the 2. My justification is that I am distributing. Okay? Now, our next step in solving this would be to subtract 6 from both sides. This step is called the inverse operation. And we do this anytime we add or subtract to eliminate something on one side. So by subtracting by 6 here, I get 3x equals 9. And why am I subtracting by 6? Because I'm performing the inverse operation. Finally, for this problem, what I see here is I have 3x equals 9. I want to get x by itself, and I'm going to do that by dividing by 3. This step specifically is called isolating the variable. Isolate the variable. And I do that because 3 divided by 3 becomes 1, or x. 9 divided by 3 becomes 3. And so now I have solved my answer, or I've solved for my equation. And so the final step is to check your work. And we do this just by plugging it back in. So I'll do 3 times 3 plus 2 equals 15. 3 plus 2 surely is 5 equals 15. And 3 times 5 is, of course, 15. So I have correctly done the problem. I have checked my work to show that it's right. And so what I'm asking you to justify, this is what I'm asking you to do. I'm asking you to show that you're distributing when you're performing distribution. You're doing the inverse operation when you're adding or subtracting. You're isolating the variable when you're dividing here. It also works when you're multiplying if there's a fraction. And then you're checking your work to show that you've successfully justified your answer. And that, as they say, is that.